Well, we have studied about the deviation produced by a prism, how the incident ray gets refracted and finally emerges out of the glass prism. So we have also done the relationship I plus E is equal to A plus D, where A is the angle of the prism and D is the angle of deviation produced. That means deviation depends upon angle of incidence. Now, question which is asked in the exams is, how does the angle of deviation depend upon the angle of incidence for a given glass prism? To explain that, we have drawn a graph over here which shows the variation. And if you look at this graph very carefully, along the y-axis I have taken the deviation angle of deviation, and along the x-axis I have taken the angle of incidence. Now, graph is a parabolic curve. We see over here graph is a parabola. Graph is a parabola. Now, as the angle of incidence increases, the angle of deviation decreases, goes on decreases. For a particular angle of incidence, deviation becomes the least, the lowest point of the graph. After that, the deviation starts increasing once again. So first angle of deviation decreases, goes on decreasing, ultimately becomes minimum, and then it starts increasing once again. So this angle of incidence, corresponding to which the deviation is the least, that is the lowest point of the graph, lowest point of the parabolic curve. So how does the incidence depend upon deviation depend upon incidence? As the angle of incidence increases, angle of deviation first decreases. It goes on decreasing, becomes minimum, and after that it starts increasing. So it goes both ways. First decreases, becomes minimum, and then starts rising once again. Very, very important question from examination point of view. You may be asked in the exams to draw the diagram also, graphical variation, and explain it. How does angle of incidence depend upon, how does angle of deviation depend upon angle of incidence? So this is what you have to draw. Draw the graph with well labeled axis showing deviation, incidence, and minimum deviation. From the graph, a freehand graph. So from here, choose the lowest point of the graph and the deviation becomes a minimum, and that's the angle of incidence, corresponding to which the angle of deviation is the least. Now, for the prism we have already studied before, this relationship I plus E is equal to A plus D. When a light of a particular wavelength or color is made to pass through a prism and the angle of incidence is such that the ray undergoes minimum deviation, that means D is equal to minimum, that lowest point of the graph, the angle of incidence is such that deviation produced by the prism for that angle is the least or minimum. In that situation, the following things must be remembered by you. If D is equal to minimum, in that case angle of incidence I becomes equal to E, and R1 is equal to R2 is equal to R. The two refractive angles in the prism, we had said mark them as R1 and R2, and they are both equal. And if that happens, in that case the ray becomes almost parallel to the base. So putting these values here, I plus E is equal to A plus D. So let's put from here equation number 1, I is equal to E. Put I is equal to E, in place of E take it as I. So 2I is equal to A plus D minimum. D is equal to D minimum. When D is equal to D minimum, this is the relationship. Work for I is equal to this. Very, very important. You might need this for your numericals. Similarly, using equation number 2, R1 is equal to R2 is equal to R, say. So we know that A is equal to angle of the prism. A is equal to R1 plus R2. So R1 is equal to R2. So 2R. R1 is equal to R2 is equal to R. So that makes it A is equal to R plus R, that is 2R. So from here we find the value of R. R is equal to A by 2. Very, very important relationships. You might require them for the numericals. So for when the prism is in the minimum deviation position, in that case I is equal to E. You can be asked these conditions. What are the conditions for minimum deviation? So prism must be kept in the, when the prism is kept in the minimum deviation position, angle of emergence becomes equal to angle of incidence. So how do we know that the prism is in minimum deviation position? We come to know by looking at the angle of incidence and angle of emergence. If they are both coming out to be equal, then the prism is in minimum deviation position, and if they are not coming out to be equal, then the prism is not in minimum deviation position. And R1 is equal to R2 is equal to R, and these are the relationships which are very, very important.